Now we have addAsync method, getAsync method, add get all entries async. Basically, they all map to this child controller, like entries, get method, and add method. As you can see, we can extract interface. Good. Now in our master service, we can inject our client. Okay, we got addAsync. Now let me implement get all entries for our master service. And basically the key thing here is that we have a lot of childs and we don't need to process them sequentially. We can send requests in parallel and then grab response one by one. Basically, when we iterate through the each of children, in each iteration we just add a child URL and this task to our tasks list, and right after we call task run, this code starts executing. And now in that point of code there already are requests to all partitions going out, and we just need to grab the response from each of them. We await task bucket task and we add response for our global response, task URL and our buckets, and we return our response. Great. And another method for child client is get. Pretty trivial one. You just get key and cancellation token. If someone doesn't know why we use cancellation token, it's just for cancellation asynchronous operations. It doesn't matter so much. You can just omit it and don't use it if you don't want to. But as a best practices, we should use cancellation token. Okay, calculate hash. Again, we should determine one particular child from which we will read. Okay, cool. Now we can extract the interface from master service because we're done with that. And one more thing for today, I'm gonna to implement replication, but we will not test it today. I'll show you in the next video when we will set up our Docker and our deploy. I will show you the demo of the overall system with replication partitioning in the next video. Okay, and as I explained in this architectural picture, some kind of in the stage of adding to master service, in case we got success, we also should replicate to other slaves, I mean other masters which are not master actor, which are slaves. And therefore we should implement another service which is called like replication service. Let it be like that. And basically in this particular service we are going to replicate and in order to replicate we also should create and encapsulate this behavior in master client, and the responsibility of master client will be to send requests to another master instance, not to child instance. One important thing here, when we try to replicate to other followers, like another master instances, the important thing is to track any errors during this synchronization, because in case you didn't synchronize, actually you have inconsistencies in your data, and this is the problem, because all reads and all reads which go to this inconsistent master, or sorry, follower instance will got not full data, and this is the problem. You should track somehow that. In my case I just log it and go out, because it's like prototype and happy path implementation right now. But yes, we need to handle it somehow, just for you to know. We also don't need to sequentially await every synchronized request. We can do it in parallel, and just after that we just handle request by request, or sorry, response by response. Okay, and by that point we return all of the tasks, and this task, which is returned by whenAll method, will return from it in case all tasks here will be finished, or at least one of them will throw exception. And actually we will not wait until this method is finished, because we use asynchronous replication. We don't need to wait until all synchronization requests are finished. Therefore just extract interface. Yes, and we don't await to this, because as I said before, we are using asynchronous replication. We just return OK to 100, and that's all. Now for sure we need to implement this request handling, because this client, this request, which is HTTP post to the slave URL /key, therefore we should implement it in master controller, this request, in order we can synchronize if this is a slave. Also we need to implement enum in order to have a convenient way to check whether our current master is an actual master, or it is like follower in our replication system. And in order to check it in the clean way, it's better to keep them in separate like model, and as Microsoft suggests to us, we should implement our enums like that. Okay, in our receive replication request, we just check whether this particular instance is not a master. If it is master, we cannot receive replication request because we synchronize between slaves from master, not vice versa. And then if it is slave instance of our router, aka master, then we can just add the same key, the same value for our partitions, for partitions which are managed by this slave master, you know. Okay, and now we're going just to add everything in our startup. Okay, I just want to build it, and if everything is okay, we'll just finish by that because we don't have any more time to debug it. In the next video we will set up everything up. We will have two masters, one like full master and another one is slave or follower, and for each master we will have two partitions, child 1 and child 2, and for another master also child 1 and child 2, and we will try to add something to them, get some values from them, and thanks to our monitoring tools I'll show you a little demo of our project, and this is probably all. But for today, thank you for your attention. Please don't forget to subscribe to me on every social media. Also, you can find me, it's kind of simple. You can find me on a lot of social medias, Vkontakte, GitHub, LinkedIn, Facebook, Telegram, Instagram, whatever. Please follow them and subscribe to me. And again, thank you for your attention and goodbye.